Dear students, we have to discuss about the physical properties of alcohols. Okay, here we shall consider the four important physical properties. The first one is physical state, the second one is color and odor, and the third one is boiling point, the fourth one is solubility. Okay, let us go one by one. Okay, firstly we shall discuss about the physical state. Okay, yes, you when you take the members of the alcohols, what are the members of the alcohols? The first member is the one with one carbon atom, that is a methanol. What is this? This is a methanol. And the second member is CH3CH2OH. This is ethanol. Okay, these are all liquids at room temperatures. These are all liquids at room temperature. Okay, yes. Then we shall discuss about the color and odor. Okay, yes. These alcohols are colorless. These alcohols are colorless and are having significant odor. Sometimes we may say that these have sweet or pleasant smell. Okay, so these alcohols are colorless and are having the significant odor. Okay, yes, third property is that the boiling point. Okay, see, I already told you that these alcohols are liquids at room temperature. Okay, when these exist as liquids at room temperature, definitely whose boiling point will be higher when compared to the hydrocarbons, haloalkanes, aldehydes, ketones, etc. Okay, you can say that the boiling point of alcohols is high when compared to the carbonyl compounds, such as aldehydes, okay, ketones, then haloalkanes, uh, and hydrocarbons and hydrocarbons. Okay, yes, these are having high boiling point, even ethers. Okay, yes, here you can see the order of boiling point of the alcohols. Alcohols are having high boiling point when compared to the aldehydes and ketones and haloalkanes, ethers and hydrocarbons. Okay. Yes, why the boiling point of these alcohols is high? It is due to the hydrogen bonding and its polarity. Due to its polarity, okay, the alcohols are polar in nature, and because it is able to make a hydrogen bonding. Okay, that is intermolecular hydrogen bonding. Okay, I will show you that intermolecular hydrogen bonding. Yes, see, the alcohols are polar in nature. When you take this, okay, ROH, here electronegative oxygen will have delta minus and this hydrogen will have delta plus. Okay, due to the presence of polarity, one molecule of alcohols attract the another molecule of alcohol. Okay, yes, how we can have the intermolecular hydrogen bonding? Yes, it's very simple. When you take the alcohol like this and take another alcohol molecule like this. Okay, here I told you that oxygen is having electron rich density and the hydrogen is having electron deficiency, so delta minus on oxygen and delta plus on hydrogen. Similarly, here also the delta delta plus on this hydrogen, delta minus on this hydrogen. When these are stayed nearby, so these will have the intermolecular hydrogen bonding. These will have the intermolecular hydrogen bonding. Okay, intermolecular hydrogen bonding. Okay, yes. See, what is hydrogen bonding? The hydrogen bonding means the force of attraction. The force of attraction between the hydrogen and the most electronegative elements. Okay, so what is a hydrogen bonding? What is a hydrogen bonding? It is the force of attraction between the hydrogen and most electronegative elements. What are the most electronegative elements? You may take fluorine, then oxygen and nitrogen. Okay, when there is a force of attraction between this hydrogen and the most electronegative elements like fluorine, oxygen and nitrogen, then such force of attraction is said to be hydrogen bonding. And here between the molecules, between the alcohol molecules, there is a such bonding, hence it is a intermolecular hydrogen bonding. Due to these two reasons, that is a polarity and intermolecular hydrogen bonding, the boiling point of the alcohols is high. Okay, and in case of the homologous series, the boiling point increases with increase in size. Okay, the boiling point increases with increase in size. For example, in case of homologous series, order of order of boiling point, order of boiling point in homologous series, that is, as I already told you, with increase in the size, surface area of the molecule increases, van der Waals forces of attraction increases, finally results in higher boiling points. For example, you have CH3OH, CH3, CH2OH and CH3, CH2, CH2OH. Here the boiling points will vary in this way. Okay, that is, the boiling points of propanol is high than the ethanol. Ethanol is having higher boiling point than the methanol. It is because of increase in the surface area. Okay, so I can say that BP of these alcohols are directly proportional to surface area of the molecule. Okay, surface area of the molecule, and you can say this is nothing but number of carbon atoms in the chain, number of carbon atoms in chain. So I can say that as number of carbon atoms in chain increases, BP increases. Okay, and it results in greater van der Waals forces of attractions. Okay, okay. So here you must understand this as BP of alcohols increases with increasing surface area and van der Waals forces of attraction. This is all in case of homologous series. Okay, what about the order of boiling points in case of isomeric alcohols? I will show you that in isomeric alcohols. In isomeric alcohols, we need to be very careful while giving the reasons for this. Okay, let's take a butyl alcohol. For example, we shall take a butyl alcohol, and you know this has four isomers. This has four isomers. Yes. Here we shall consider the CH3, CH3, okay, and OH here, and CH3 here. This is a tertiary butyl alcohol. This is a tertiary butyl alcohol. Okay, and let's consider some secondary butyl alcohol, or we shall consider some isopropyl isobutyl alcohol like this. CH3, CH2, okay, CHOH, or some CH3. Okay, so this is a secondary butyl alcohol. Okay, this is a secondary butyl alcohol. Okay, yes, let's consider another alcohol, that is normal or a primary butyl alcohol like this: CH3, CH2, CH2, CH2OH. So this is a primary butyl alcohol. Okay, these are all common names of the molecule. These are all common names of the molecule. Say here, which one is having a large surface area? Undoubtedly, it is having larger surface area. Okay, and it can have more van der Waals forces of attractions. Okay, come to this has a somewhat small surface area when compared to this, therefore it will have less boiling point. And come to this, okay, this is having still short surface area, so therefore its boiling point will be very less. Okay, so due to these reasons I can give you the order in this way. Okay, yes, here the due to increase in surface area from tertiary to secondary to primary, the boiling point of alcohols also increases in the same way. This is in case of isomeric alcohols. This is in case of isomeric alcohols. Okay, next the another property is the solubility. Okay, another property of the alcohols is its solubility. Okay, yes, let's consider the solubility of alcohols. Yes, here when comes to the solubility, here there are two types. One is whether we are talking about solubility of alcohols in water or solubility of alcohols in other organic solvents. Yes, see here, the alcohol, it is an organic compound, so it definitely dissolves in other organic solvents. Okay, we know that like dissolves in like. Okay, like dissolves in like. It means the organic compound. It means that organic compound alcohol is readily soluble in organic solvents, like benzene and CCl4 ethers, etc. Okay, say organic compound alcohol is readily soluble in organic solvents like benzene, carbon tetrachloride and ethers. Okay, and let's consider the second one. The first few members are readily soluble in water. Okay, we can say that alcohols are soluble in water. Alcohols are soluble in water. Okay, alcohols are soluble in water due to two reasons. Again, the polarity and the hydrogen bonding. Due to polarity and intermolecular hydrogen bonding or we can say simply hydrogen bonding. Okay, or we can say simply hydrogen bonding. Okay, yes, here let us consider how these alcohols are soluble in this water. Yes, here when you take the general structure for alcohols, this is ROH, and you take the structure of water, this is like this. Okay, and take one more for the structure of alcohol, for example like this. Yes, here you know that oxygen is most electronegative element, therefore electron density on this is high, and here it is delta plus, here also it is delta plus, it is delta minus, it is delta plus, and it is a delta plus, it is a delta minus. Okay, yes, this is an alcohol, this is water, this is again alcohol. Okay, yes, here the force of attraction between the hydrogen and the most electronegative element is called as hydrogen bonding. Yes, due to this polarity, unable to make hydrogen bonding with the water, the alcohols are soluble in water. Okay, yes. Okay, here also there is a hydrogen bonding, here also there is a hydrogen bonding, here also there is a hydrogen bonding. Because of these reasons, it is soluble in water. Okay, I can say one more point that in homologous series, as the number of carbon atoms in the parent chain increases, polarity decreases, solubility decreases. Okay, solubility, solubility of alcohols, solubility of alcohols decreases, decreases with size of alcohol, decreases with the size of alcohol. Okay, solubility of alcohols decreases with size. Okay, so this is all about the physical properties of alcohols. Hi dear students, now we shall discuss about solving the problems on our previous discussion, that is on the classification nomenclature of the alcohols. Okay, so the first question is that classify the following as primary, secondary and tertiary alcohols, and also identify allylic and benzylic alcohols in the given compounds. Okay, let us take the first compound. I already told you how to determine the primary, secondary and tertiary alcohols, and also the allylic and benzylic alcohols. We shall just recall the discussion how to find out the primary, secondary and tertiary alcohols. Okay, so here I am going to show you that a primary alcohol is the one in which the OH group is present on the primary carbon. So how to determine that primary carbon? So we have the definition which states that a carbon linked to only one other carbon is called as a primary carbon. For example, we have like this. Here OH is present on this carbon. This is linked to only one other carbon. Hence, this carbon is said to be a primary carbon and the alcohol is called as primary alcohol. Okay. Yes. Then what is the secondary alcohol? When OH group is present on the carbon which is linked to two other carbons. For example, CCCOH. Here you can see that OH is present on this carbon. It is linked to two other carbons. Okay, hence it is a secondary. Okay. Now, how to find out the tertiary? Yes, it's also simple. If a carbon holding the OH group is linked to three other carbon atoms, then we call this as tertiary. Okay, and the alcohol is said to be a tertiary alcohol. Okay, let us find out first the primary, secondary and tertiary alcohols in the given compounds. Okay, now come to this compound. Here OH containing carbon is this. It is linked to only one other carbon. It is linked directly to the one other carbon. Hence it is a primary alcohol. Hence it is a primary alcohol. Okay. Yes. Similarly, come to this compound. Here OH containing carbon is this. It is linked to only one other carbon. It is linked to only one other carbon. Therefore, it is also a primary alcohol. It is also a primary alcohol. Okay. Come to this compound. Here OH containing carbon is this, and it is linked to only one other carbon. Therefore, it is also a primary alcohol. Okay. Yes. Come to this compound. OH containing carbon is this. It is linked to this carbon. Here it is a benzene ring, means it is nothing but having carbon atom. Okay, at all these positions. Okay, now this carbon is linked to this carbon and this carbon. Hence, this carbon is a secondary carbon, and the alcohol is a secondary alcohol. And the alcohol is a secondary alcohol. Okay, now come to the fifth compound. Here OH containing carbon is this. It is linked to two other carbon atoms. Hence it is also a secondary alcohol. It is also a secondary alcohol. Now the sixth compound OH containing carbon is this. It is linked directly to the three other carbon atoms. Hence it is a tertiary alcohol. It is a tertiary alcohol. So in this way we have to find out the primary, secondary and tertiary alcohols. Okay, and the question is also identify the allylic and benzylic alcohol. Okay, now we shall recall what are allylic alcohols and what are benzylic alcohols. Yes, allylic alcohols must follow a sequence R CsP2 CsP3 OH. I already told you this in the previous class. Means allylic alcohol is an alcohol in which the OH group is present on the sp3 hybridized carbon, which is next to the sp2 carbon and containing C double bond C. Okay. Now let us see what is benzylic alcohol. Yes, benzylic alcohol is the one. It must have this sequence AR CsP2 CsP3 OH. Here the OH group is present on this carbon sp3 hybridized carbon, which is next to the benzene ring. Okay. So with this discussion, let us find out what are the allylic alcohols and benzylic alcohols in the given list of compounds. Okay, come to this. This is the OH containing carbon. It is having sp3 hybridization. Okay, and this carbon is also having sp3 hybridization. Now it is not matching with that sequence. Okay, here in this sequence you can see that OH is present on sp3 carbon next to sp2 carbon. Here also OH is having sp3 carbon next to sp2 carbon, and it is not matching with that. So it is not neither allylic nor benzylic. Okay, now come to this compound. Here it is the sp3 carbon, it is the sp3 carbon and it is sp2 carbon. It is not having any cyclic structure or benzene ring. Therefore, this is the allylic part. It follows this. So, this compound is allylic alcohol. This compound is allylic alcohol. Okay. Yes. Come to the third compound. Here OH containing carbon is sp3 and this carbon is also sp3. Okay. So it is also neither allylic nor benzylic. Okay. Come to this fourth compound. Here OH containing carbon is sp3, okay, and it is next to the benzene. Therefore it is benzylic alcohol. Therefore it is benzylic alcohol. Yes, come to the fifth compound. OH containing carbon is this, and it is having sp3 hybridization, and after this we have sp3 carbon. Here also sp3 carbon. Okay, OH containing carbon is sp3 and it is next to the sp3. It is not matching either with this or with this. Okay, therefore it is also neither allylic nor benzylic alcohol, and don't get confused with this benzene ring. Some questions will be like this, and those will be given to confuse you. In the benzylic alcohols, we say there must be benzene ring. But where that benzene ring is present, it is not next to the functional group containing carbon. Okay, it is here. Okay, therefore it is not a benzylic alcohol. Okay, for benzylic alcohol, you must follow that sequence. OH group containing carbon must be sp3 hybridized, which is next to the sp2. But in this case, here OH containing carbon is sp3, which is next to sp3 again. Okay, therefore this is neither benzylic nor allylic alcohol. Okay, let's come to the sixth compound. Here OH containing carbon is this. It is having 4 sigma bonds, hence it is sp3 hybridized, which is next to the sp2 carbon. Okay, yes, therefore, and when comes to this is the alkyl part. Okay, so therefore OH, sp3 carbon, sp2 carbon, hence this is an allylic alcohol. This is an allylic alcohol. Don't confuse with this benzene ring. It will be given to confuse you. That's it. Okay. So we have easily solved the types of alcohols, that is primary, secondary and tertiary alcohols, and we have also identified the allylic and benzylic alcohol. Keep in mind these sequences. These are very important also. Okay. Now we shall consider this question, that is, give IUPAC names of the following compounds. The first compound is that here we have to identify the major functional group, which is the major functional group, and there are no other functional groups. And what are these? Cl, CH3, CH3 are the substituent groups. Okay, functional group is OH, the chlorine, CH3 methyl, methyl groups are just the substituent groups. Okay, yes. Now what is the prefixes here? So I already told you, while writing the IUPAC names, you must have the sequence like this: prefix, word root and suffix. It is nothing but the IUPAC. It is nothing but the IUPAC name of the compound. Okay, and here we have to list out the prefixes. Here first we shall number the carbon atoms, find out the word root. Okay, it is the major functional group and containing carbon is the numbered as 1. This carbon is 1, 2, 3, 4, 5. Okay, and it covers the maximum number of the carbon atoms with the major functional group is called as a word root. Okay, and these are all prefixes. Okay, here prefix is Cl and it is chloro and it is a CH3 methyl. C of chloro comes first alphabetically, then the M of methyl. And what is the position of this chloro? 4. So we can write 4 chloro. We can write 4 chloro. And next there are two similar groups present. At this case we have to take di, okay, because two groups are there, no? And what are the positions of these 2 and 3? So we can write 2 comma 3 dimethyl, 2 comma 3 dimethyl, okay. And what is the word root? It is containing 5 carbon atoms, therefore penta, okay. And OH group is present on the first carbon, so therefore it is pentan 1 OL, okay. I can write that here, pentan 1 OL, okay. So now what is the IUPAC name of this compound? 4 chloro 2 comma 3 dimethyl pentan 1 OL. So in this way you have to write the IUPAC name of the compound. Here you can see that 4 chloro 2 comma 3 dimethyl is the prefix and pentan is the word root, OL is the suffix, okay. Yes, and we shall consider the second compound, okay. Here there are functional groups at this position and at this position. Here we shall find out the word root. Word root is the one which is covering maximum number of carbon atoms and having the functional group. Okay, let us come from here. Let us consider this as carbon 1, this as 2. If you go this side, you will have 3 and no continuation. Okay, so that is why we shall move this side, and here you can have the third carbon atom and fourth carbon atom, fifth carbon atom. You can give number 6 to this carbon or to this carbon, it makes no difference. Okay, let's give number 6 to this carbon, okay. Yes, now we have to follow the IUPAC sequence. This is prefix plus word root plus suffix, okay. Prefix will be given for the minor functional groups or the substituent groups. Okay, here the functional groups are OH and substituent groups are this methyl. It is not numbered, then it will be considered as a side chain, and it is also not numbered and it is also considered as a side chain or the substituent group, okay. Yes, there are two substituent are the chains, okay. Here for these two substituent groups, what are the positions? The 2 and 5. So let's write 2 comma 5 dimethyl, 2 comma 5 dimethyl, okay. And what is the word root here? Prefix is over, prefix is given for the substituent groups, okay. And what is the word root here? Containing 6 carbon atoms, hence it is hexa, okay. Here all are saturated carbons, so you can write hexane, okay. And where there are functional groups at the position 1 and at the position 3, there are two OH groups, so therefore you should have this E, you should not replace that E, okay. That must be there when more than one similar functional groups are present, okay. Now hexane and position of the OH groups are 1 and 3, 1 comma 3 diol, 1 comma 3 diol. So this is the IUPAC name of this compound. See, whenever only one functional group is present, like here you have replaced the E with OL, but when more than one similar functional groups are present, you should have that E, okay. Yes, next come to this third compound. Here it is a cyclic compound, so you should have the cyclo in the word root, okay. And it is the OH is the functional group, Br is the substituent, okay. And here, what is the position? The major functional group containing carbon must take the least number. We shall give 1 to this carbon, and if you move in this direction, it is 2, it is 3. But if you move in this direction, it will be 2, 3, 4, and it would be 5. So it should not happen. We have to follow the lowest sum rule. According to that rule, we have to follow in this order so that this bromine will be reached soon. Okay. So now the prefix will be given for the substituent and its position is 3. 3 bromo, 3 bromo, cyclo, and how many carbon atoms are there? 1, 2, 3, 4, 5, 6. So 6 carbon atoms are there. So let's take hexa, and all are saturated carbons. You can write hexane. And we have the functional group OH at the carbon 1. See here, only one OH group is present. So now you have to replace this with the OL and its position is 1. Okay. Now the IUPAC name of this compound is 3-bromo cyclohexane 1-OL. So like this you have to write the IUPAC name. Okay, come to the next compound. Here it is a benzene ring and methyl groups are substituents for which prefix will be given, and the functional group is OH. So here we can consider the OH containing carbon as 1. You may give position to this carbon as 2, 3, 4, 5, and it is 6. It is 6. Okay, now let's write the IUPAC name of this compound. Consider the substituent groups. 2 CH3s are present and whose positions are 2 and 6. Let's write the prefix 2, 6 dimethyl, 2, 6 dimethyl. Okay, and the benzene. So benzene we have, so we can write the benzene. See, only one OH group is present. Now you have to replace this E with the suffix of the functional group where it is present on the first carbon, benzene 1-OL. This is the correct IUPAC name of the compound. And here for this part, that is benzene ring with the OH group, we can also call this as phenol. Okay, now we can also have the another IUPAC name as 2, 6 dimethyl phenol. So what is the difference here? You may call benzene 1-OL or phenol. Both are considered as IUPAC names. Okay. For phenol, we can call benzenol. Okay. Yes. Come to the fifth compound. Here we have two functional groups. One double bond and another one is OH. Here OH is considered as a major functional group and containing carbon will be numbered as 1. Okay, this is 1, 2, 3. You may give number 4 to this carbon or this carbon. It makes no difference because these are the terminal carbon atoms. These are the terminal carbon atoms. Okay, now what are the substituent groups here? There are two substituent groups. One is CH3 and another one is bromine. Okay, yes, where the which substituent groups come first alphabetically. The B of bromo comes first. So 2-bromo, 3-methyl, and these are the prefixes. Okay, and word root it is containing 4 carbon atoms in the parent chain. So for that you can take but, and here ene is present. Where it starts, when you move from left to right at the second position, the double bond is started. Okay, therefore but to ene, where the OL is present on the first carbon, so it is 1 OL. So now this is the correct IUPAC name of the compound. So what is the IUPAC name of this compound? 2 bromo 3 methyl but 2 ene 1 OL. So in this way you have to give the IUPAC names for the compounds. Use this sequence, then it will be easy. Okay.